Okay, so let's take an opportunity to kind of compare two different atoms and see if you can determine which of the three kinds of chemical bonds are going to be present in these different examples. Remember, we're going to take the difference in the electronegativity values to make that determination. So, I'd like you to watch the video 3.1 on polar versus nonpolar bonds just to get a little more background on this. Okay, so let's start with sulfur and bromine. So what I want you to do, you can get out a calculator if you want, and I want you to take a look at these three elements and see if you can determine what kind of chemical bond you're going to say it is. So in the case of sulfur, I'll help you through this first one. Sulfur has a 2.58 electronegativity, and bromine has a 2.96. So you're going to look at the difference between those two values. You're going to go 2.96 minus 2.58. And so what do you get? You should end up with 0.38. And since 0.38 is less than 0.4, we're going to classify that as a nonpolar covalent bond. We're going to say that more or less these are about equal in their pull. All right, let's try carbon and oxygen. Carbon, 2.55. Oxygen, 3.44. If we were to subtract the difference in those, we get about 0.9. 0.9 is greater than 0.4, but less than 1.6. So we're going to classify that as a polar covalent bond. The electrons are going to spend more time near the oxygen than they are near the carbon, because oxygen has the higher electronegativity. All right, now let's take a look at hydrogen at 2.2, and then oxygen again at 3.44. Looking at the difference there, the difference is about 1.2, which again is between 0.4 and 1.6. So we're going to classify that as a polar covalent bond. Now the difference between these two is that this one was 0.9 was the difference, and this one was 1.2. So we would actually say the oxygen-hydrogen bond's a little more electronegative in difference, so it's a little more polar. They're both classified as polar covalent bonds, but the OH bond is more polar than the OC bond. All right, you try it. Let's go with oxygen and chlorine. You can pause the video, do the calculations. Let's see what you get. Okay, so if we take a look at the oxygen-chlorine bond, we'll notice 3.44 versus 3.16. Those are pretty close to each other, and we would say that these are non-polar covalent bonds. All right, how about C and H? Subtract the difference there, you get 0.35. That's less than 0.4, so we're going to say that's a non-polar covalent bond. And then we have H, hydrogen, and N, nitrogen. The difference there, about 0.8, that is a polar covalent bond. The electrons spend more time near the nitrogen than they do the hydrogen. All right, so let's take a look at KCl, potassium and chlorine. Well, potassium, where's that at? It's over here at 0.82, and chlorine is over here at 3.16. The difference there is 2.5, which is much greater than 1.6. So we're going to say that that one is ionic, where the electrons are completely removed from the potassium. So potassium becomes a positive ionic K+, and chlorine becomes a negative ionic Cl-. All right. I accidentally gave you the answer to OSI. We've got 3.14 for oxygen. We've got 1.9 for silicon. The difference there is less than 1.6. It's pretty close to being ionic, but it is polar covalent. And finally, we've got phosphorus, 2.19, and oxygen, 3.44. The difference there is about 1.2, so it's polar covalent. So that's how you can tell the different kinds of chemical bonds that will happen between two atoms. Take the electronegativity values and subtract the difference. If you're wondering where do I find these values, if I'm just happen to look at a chemical reaction, it's on the chemical reference sheet that I gave you at the beginning of the school year. All right, so that's it.